Okay, basically we just go over homework problems. We are done with concept. Yes! With practice test. Which is Conic 5. Yeah. You've had this course for, oh my God, 2 quarters already. Okay, everybody back up 1 foot. Okay, which ones are we doing? 2, 3, 4, 5. How come you guys? Okay, here. This is what's concerning me. How come you could do the same problem on Conic 3, but now it's on Conic 4 and you can't do it? Yeah, that's right. Okay, these 2 fixed points are the foci. So the center is going to be halfway in between, which is 1, 2. And this is a left-right hyperbola, right? Now the differences of the distance is 6. What's the significance of this constant? That's 2a. 2a is the constant, remember? In the ellipse and a hyperbola, whatever the constant is, that's 2a. So in this problem, 2a is 6, which means a is 3. But we know the distance from the focus is c, which is 4, so we know c is 4. And if you know a and c, how do you figure out b? C squared equals for a hyperbola? A squared
plus b squared.
Right. So 16 is equal to 9 plus b squared, which means b squared is equal to 7. So now that you know the center, you can write the whole equation. It's going to be x minus 1 squared over a squared, which is 9, minus y minus 2 squared over b squared, which is 7, equals 1. Finished. But of course, if you don't know that the constant is 2a, then it's very difficult. Yeah? You have to know that the constant is 2a for the ellipse and the hyperbola. Okay, number 3. Isn't this like the same problem you had in today's quiz, except it's a hyperbola? You guys are fantastic. One focus is at -2, 4, and the corresponding directrix is y equal 11 fifths. Now, where is 11 fifths? Is it up there or down there? It's down here. Well, the last time I looked, 11 fifths is 2.2. Oh, that's not right. Yeah, that's right. It's 2.2. And that's 4. 2.2 is smaller than 4. So, if this is a hyperbola, you got to remember this is a hyperbola now. It's a hyperbola. That's one branch. Where is the center going to be? No, well, we don't know, but it's down here somewhere. If you can figure out where the center is, that's pretty much the whole problem. Now, in a hyperbola, what's the distance from the center to the directrix? A squared over c. What's the distance from the center to the focus? C. And what's the distance between 11 fifths and 4? I'll give you a hint. 4 is 20 fifths. 9 fifths. So look at this picture. What equation can I write? This plus this equals that. Hey, that's like the one on today's quiz. I didn't do that on today's quiz. No, because you probably didn't get it then. So a squared over c plus 9 fifths is equal to c. Now I need another equation. It says the eccentricity is 5/4. So we know that c over a is equal to 5/4. You use these two equations to solve for a and c. Okay, why don't I just do it since we're being videoed. What do you want to do? Solve for a or c? A. Are you sure? Isn't it easier to solve for a? But it's up to you. So 5a is equal to 4c. A equals 4c over 5. Take that and plug it in here. So that's going to be 16 over 25 c squared divided by c is just c plus 9 fifths equals C. So 9/5 is equal to, subtract 16 over 25, 9/25 C. Therefore, C equals, look, it comes out beautiful. 5. Which means, of course, A is 4. So if C is 5, that means the distance from here to here is 5. Therefore, if I go 5 units down from the focus, where am I going to be? -2, comma, -1. And if you got the center, you can write the whole equation. This is an up and down hyperbola, so the y comes first. So y plus 1 squared over a squared minus x plus 2 squared over b squared equals 1. Well, we already know a is 4, so a squared is 16. And if you know c and a, how do you figure out b? There, this equation again. C squared equals a squared plus b squared. So 25 is equal to 16 plus b squared. Therefore, b squared is 9. And there you go. Okay, I'm going to tell you right now, this problem is going to be on the test. I think I already told you already. This problem is on the test. You got to be able to repeat this one. It's not that hard, just draw the picture. Okay, number 4 and 5, 4. Okay. Here are the two asymptotes. I'm going to put -10. And 4x plus 3y equals 2. One foci is at the point 14, comma 2. Okay, how can I figure out the center of this hyperbola? Where the two asymptotes intersect. So if you just add the equations, you get 8x is equal to -8. X equals -1. Plug that in. So you get 3y equals 6, y equals 2. You figure out the center. Now, if the center is at -1, 2, and one focus is at the point 14, comma 2, what kind of hyperbola is this? If the focus is to the right of the center. It's a left-right hyperbola, which means the x comes first. And since you have the center, x plus 1 squared over a squared minus y minus 2 squared over b squared equals 1. Well, I know the distance from the focus is c, so what is c? C is, how far is it from -1 to 14? 15. So I know c is 15, but I need a and b. How do I figure out a and b? I only know c is 15. The slope of the asymptotes. What are the slope of these two asymptotes? This one is 4/3, this one is -4/3, yeah? Now, if you have a left-right hyperbola, are the slope of the asymptotes plus or minus a over b? Or is it plus or minus b over a? It's in the notes! Or just look at the box that you drew, but we didn't draw a box. b over a is equal to 4 over 3. Oh, Mr. Park, we gotta know everything. Duh. So if b over a is 4 over 3, does that mean b is 4 and a is 3? No, that means the ratio is 4 to 3. So how do I figure it out? You know c is 15. What equation is always works in a hyperbola? C squared is equal to a squared plus b squared. Oh, but you know c is 15. So c squared is 225. You got two equations, two variables. Solve it. So solve for either a or b. Okay, b is, this implies b equals 4/3 a. Take that and plug it in here. So you get 225 is equal to a squared plus b squared, which is 16 over 9 a squared. So 225 is equal to 9/9, so that's 25/9 a squared. So a squared is equal to multiply by 9 and divide by 25. 81. So a squared is 81. And once you know a squared is 81, how do you figure out b squared? And you get 144, and there you go. You have to put all the pieces together. So again, this is exactly like the test. When you describe a hyperbola, you have to write the equation. Okay, and then number 5. Okay, here we go. I'm going to describe a conic section. You're not going to know what it is, but you have to like write the equation. Write the equation of the set of points of the Cartesian plane twice as far from 7, 2. Okay, here's the point 7, 2, as from x equal 1. So twice as far from there as from there. So here's a representative point, x, y. This distance is twice that distance. So twice as far from there as from there. Okay, how do you find the distance from here to here? What do you do? Do I have to do the distance between a point and a line? No. If it's on a vertical or a horizontal segment, what do you do? Right minus left. What is the x coordinate here? What's the x coordinate there? So what's right minus left? And how come you gotta go right minus left? Yeah, because that guarantees it's positive. Okay? And then how do you find the distance between these 2 points? Distance formula. Okay, but this one is twice that one. So I have to multiply one of them by 2. Which one do I multiply by 2? Do I multiply the bigger 1 by 2 and make them more unequal? Or do I multiply a smaller one? Yes, you multiply the smaller one by 2. But I already know, because every single year this happens. I would say about between 6 and 12 of you are going to put the 2 on the wrong side. But that's okay. Take the minus 3 or 4 and just... No, because if you don't finish the problem, then you're going to get minus 8. No, but the problem is worth 10 points now, right? Because there's only 7 problems on the test. So take the minus 5 and go on. Or whatever. Okay, so there. That's your answer, except you got to simplify this. Because right now, do you guys even know? Do you guys even know what it is? It's on the hyperbola worksheet. It's a hyperbola, but on the test, you're not going to know. So that's why you're going to have to square both sides, complete the square, and put it in standard form. Okay, I will let you do that because that's just algebra. Okay, any other questions you sure you want to go over? Okay, number 7, that's going to be a tilted hyperbola. Just like today's one was a tilted ellipse. And you guys got the secret for polar? Yeah, like number 6, polar. One problem on the test is going to involve polar. What do you want me to do, number 6? Nani?
Oh, can you do the directrix for that one?
Okay. Number 6. R equals 10 over 2 minus... How do I know that this is going to be a hyperbola?
Minus.
No.
Oh, wait,
you
no,
said
no.
that yesterday. Because the eccentricity is 3 halves, which is bigger than 1. So you know it's going to be a hyperbola. But you really don't need to know that. All you got to do is plot the 4 quadrantal angles and all is right with the world. 0. 5. 1, 2, 3, 4, 5. Pi over 2. Negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pi. 5. 1, 2, 3, 4, 5. And 3 pi over 2. 2. 1, 2. Now you got to go 2 units in that direction now. Don't go 2 up, because if you go 2 up, then it's going to be an ellipse. But it's not. So here's one branch of the hyperbola, and then here's the other one, my pretty. One focus is always at origin. What's the other focus? Well, if you got to go 2 that way, duh, you got to go 2 that way to get to the other focus. So this other focus is going to be 0, negative 12. Right? You go 2 that way, you got to go 2 that way. And how do I get the direction? Where's the center, by the way? 0, negative 6. No, it's halfway in between, right? Now, how do I get to the direction C? Well, you need to know A squared over C. Well, A is the distance from the center to the vertex, which is, just count, 4. 4 squared, oh, just like 4 squared. C is the distance from the center to the focus, which is 6. So this comes out to 16 over 6, which is 8/3. So all you gotta go is 8/3 up, whoo, and 8/3 down, whoo, and those are your 2 directrices. So if this is negative 6, which is, what is negative 6? Negative 18 thirds. If I go 8 thirds up, what are you going to do? Negative 10 thirds. And then if I go 8 thirds down, you're going to be negative 26 thirds. And those are your two directresses. Everything is counted from the center. Once you figure out the center, the problem's pretty much done already, yeah? Okay. Okay, so tonight's homework is just this practice test, right? Are there any surprises on that? Let me know. I don't think there's going to be surprises on this test, but for you guys might think it's a surprise because you guys don't do your homework. Yeah? Let's see. The only problem that you haven't seen before is number 6. All the rest you've seen before. Okay, I'm telling you, this test is usually not good, so make it happen. Because this test is not the next chapter is matrices and determinants. You guys studied matrices before?
No.
Yeah, you did. Kramer's rule. Does that sound familiar? Kramer's rule. What do you mean no?
I forget what it is.
If Algebra 2B can learn Kramer's rule, Algebra 2 Honors, of course, learned it. Yeah.
Oh, yeah.
Yeah, but you guys only did baby 2 by 2.
Yeah, we did 2 by 2 and 3 by 3.
We didn't do 4 by 4 and 10 by 10.
Yeah, we did 3 by 3.
You did 3 by 3?
Yeah.
What teacher is this?
Wash.
Oh, very good. But it doesn't matter. I'm going to teach you like you don't know. That chapter test is usually pretty good.
You pick a column and then you go to the numbers that are not in the column.
Oh, very good. I'm impressed. What about Mr. T?
No. No.
Skipped it.
Did we?
Yeah.
No, we
Well,
changed
we
it.
did 2 by 2.
We did like
2 by 2 and that's it.
long ones.
No, they just had a memorization speech. Next chapter is easier, and then after that, hard.
I remember there's one problem, it's a whole page just to do one chapter.
Yeah, okay. Oh, whoa! Chanel just said, hey, I'm reading something on the notes here. It said something about eccentricity is equal to PF over PD. Yeah. So, look, here. Okay, this is a Conic. Okay, anytime you have a focus, where's the focus? Here's the focus. Here's the directrix. Okay, you have a conic section. Now, this could be a parabola, but it could be an ellipse, but it could be a hyperbola. How do you tell? Well, you look at the eccentricity. If this is a point on the conic section, the eccentricity is PF over PD. Point to focus, that's what PF is, and point to directrix is PD. That ratio always stays the same in a conic section. So in this case, what is the ratio of PF over PD if this distance is double down? It's 2, so if the eccentricity is 2, that means it's a hyperbola. What if this distance were equal to this distance? Then isn't that the definition of a parabola? Which means, of course, the eccentricity would be 1. And the eccentricity of an ellipse is less than 1, so that means this distance is going to be smaller than that distance in an ellipse. As it turns out, though, we compute the eccentricity just by doing C over A. But this is actually what eccentricity is. It's just the ratio of this distance to that distance. Yeah, whatever. At least somebody's reading the notes. Does that answer the question? No. The ratio is C over A. The ratio of PF over PF. But that doesn't mean PF is C. No, because the point can be anywhere along the curve. Whatever conic section you have, the point can be here, there, and there. The ratio of the distances is always the same.